Can you please tell me about yourself?
Yeah, hi. So I have a total of 3.5 years of experience on Java, Spring Boot, and microservices. And I am currently working as a senior Java full stack developer at Technova Digital Systems. And over the years, I have worked on building scalable backend services using Java 8, Spring Boot, REST APIs, Hibernate, and Kafka. Apart from that, I also have experience with Docker, CI/CD pipelines, and I also do the cloud deployments. And on the front end side, I have worked with React and JavaScript to build the responsive user interface. And my most recent project was based on the e-commerce application. So yeah, that is what is all about myself.
Okay, can you please tell me about your most recent project?
Yeah, my most recent project is an e-commerce application. So that is built using the microservices architecture. So basically, the goal of this project was to create a scalable, high-performance system, and that could handle the high traffic basically. So it can also handle the real-time updates, and also the main focus was on the smooth user experience on all the different platforms. So in this project, there were several modules which we developed using microservices like a user service, then product service, then order service, notification service, and inventory service. So like that, we had several different type of services were there. Every developer was assigned with the individual module, and they had to work with that. And to enable the communication between these services, we were using Kafka as a event streaming platform. And Kafka basically helped us to achieve asynchronous communication. And so, like for example, whenever the order was placed, so the order service publishes an event, and the inventory service consumes it to update the stock. So that is how we were using Kafka. And the front end of the application was built using React. So that we used for the smoother user interface. And for the data storage, we were using the MySQL. And each services basically had its own database, and a few services were also using the MongoDB. So this is what is all about this project. Yeah.
And what you did in this?
Yeah, so I was also assigned with a few of the modules, and my major responsibilities was to like designing and developing the microservices with Spring Boot, and I also created REST APIs for product order and user modules, and also I worked on the React components for the user dashboard and product pages. We were also using the JPA and Hibernate queries for the database operations. So these are the things mostly I did. Yeah.
Okay, so some of your module used MySQL and some of your module used MongoDB, right? So can you tell me the reason behind that?
Yeah, basically we used both MySQL and MongoDB. Based on the requirement, and basically the some modules were using MySQL because MySQL is the relational database structure. So like whenever we have the relationship between the tables, and based on relationship, if we want to fetch the data, insert the data, or whatever we want to do, we can do that. And complex join queries and relationships, so all those things we can do that. And consistency also will be like kind of strict in this relational databases, like in my. And whenever we are using MongoDB, so in that case, like it is kind of, we can say, flexible. So it is no SQL, and it is flexible, and there is no like schema kind of. So it is a schema-free data storage. So the read and write will be faster in this case. And whenever we are handling large or dynamic JSON document, so in that case, we can go for the MongoDB. And there is no relationship concept also is not there in this. So we say here like document instead of tables. We have here document. And so for example, mostly we use this, let's say items we are selling. Let's say we are selling TV, okay, TV or clothes. So TV will be like television will have different properties, right? So it can be, it's the size will be like whatever, 32 inch, 43 inch, so that will be different sizes will be there. And also like it's flat or it's oval. So those kind of properties are there for the television. But suppose again we have the cloths, so it will have different properties. So we are not strict to the similar kind of properties, right? So in that case, MongoDB is kind of very much useful. So different types of properties we can hold for different type of objects in this case. So in this kind of scenarios, MongoDB we can use, but MySQL we will be using for the relational databases. Yeah, that's the difference between these two and why we used it. Yeah.
Okay, so why did you use Kafka instead of RabbitMQ?
Kafka we used because of I think Kafka we use for the high throughput and performance. So it can handle basically millions of messages per second with very low latency. And also like Kafka, not just the message broker, it is like kind of event streaming platform we can say. So it store events and allows multiple consumers to read them independently. So that basically helps us to build features like real-time inventory updates or analytics based on the product views or notification triggered from the events. So basically, RabbitMQ does not return messages in this way. That was another reason, and also Kafka scales very easily by adding more brokers and partitions. So our system basically needed to handle traffic spikes like uh, at some specific time, and Kafka basically provided that smooth scalability. So we did not have to redesign the system based on the higher traffic. And RabbitMQ basically it is mostly we use for the simple workflow or task queues. So in that case, we can go for RabbitMQ. It is traditional message queue scenarios. There we can use it, but wherever the latency is high and we have like high traffic and all is there, then we should go for the Kafka. So that is why we were using Kafka. So yeah.
Okay, so how did you integrate your backend APIs with React frontend? Can you explain in very brief?
Yeah, I integrated the backend APIs with React frontend using the RESTful API calls. So on the front end, I used Axios to to call the Spring Boot backend endpoints. So the React components triggered these APIs calls inside use effect or on user actions. So the backend returned JSON responses, and those responses were stored in React state using the hooks like we have use state, right? Or in Redux for the global state. So and for authentication we use JWT tokens. So that were stored in the HTTP only cookies or local storage and attach them to the API request using the interceptors. So overall the integration was a simple request response flow where the React consumed the REST API and the updated the UI based on the responses. So that is how we had integrated. Yeah.
Okay, and what state management approach did you use in React?
Yeah, for state management, I mainly used React hooks, such as use state, as I told you, and use effect is also there for local component level state, and also use context for the sharing state across the smaller sections of the app. So for global application level state like user data, card detail, and authentication, for them I used Redux. So Redux basically helped manage like shared state cleanly, and that avoid the uh, prop drilling and maintaining the predictable state updates using the actions and reducers. So I also used Redux for handling the async API calls. Yeah, so these are the basically states management approach I used. Yeah.
Okay, fine. So, can you tell me what are the error responses you are aware of?
Error responses are there are it can be basically of two types. Either it can be client side errors. So it starts with 400 series, 400, 403, then 404. So all of them are client side errors. And we also have server side errors. So that is of 500 series. So like 500, 500 and 2, 503, 504. So these are the server side errors. So yeah.
Okay, so can you tell me when exactly you can get 400 response? So what can be the scenarios?
So 400 is basically bad request. So that is the request is invalid or missing required data. So in that case, 400 response is user receives. So main it's common situations can be sometimes it can be maybe missing required fields. So suppose we are not sending the email or password in a login request. So in that case, we can receive this 400. Or suppose the data format itself is invalid. So let's say we are sending a string instead of a number, or invalid JSON we are sending. So in that case also we can get 400. And also let's say structure itself is wrong. The request whatever we have provided, so maybe so sometimes along with the in the payload we also have the headers and all. So if we missed the headers or some like wrong information we gave, so in those kind of scenarios also we can get 400. So yeah, so these are scenarios I can recall right now. Yeah.
Okay, so let's say if two microservices need to use the same DTO or model class, so how do you manage sharing this object while maintaining the proper versioning and dependency control? So can you tell me?
Like to share the common DTO between the multiple microservices, so we can use a separate shared module, sometimes called common or core module. So basically this module generally contains all reusable DTOs and utility classes and constants that multiple services may need. So we package this common module as a Maven Gradle library and publish it to our internal repository. So each microservices then adds a dependency on the specific version of that shared module. So this approach versioning has various benefits also basically. So it is basically not tight coupled, so it is loosely coupled, and also the consistency will be maintained across all the services. So yeah, so that is how we can do that, and it is generally we do that whenever we have this kind of scenario. Yeah.
Okay, now let's say if one microservices need to change the DTO. Okay, so earlier let's say like two microservices were sharing the same DTO. Now one microservices need to change the DTO. Okay, but another does not require it. So how do you handle that?
Yeah, if one microservices need to change and other does not, then I can handle it through the proper versioning and backward compatibility updates. So I can use semantic versioning for the shared DTO library. So if the changes is non breaking, so adding a new field, so we release a minor version. So suppose it was 1.2, then we can make it 1.3, and both services can choose when to upgrade. Okay, so if the changes is breaking, then we can release the major version. So based on the versioning we can maintain that, so we can keep the DTO backward compatible whenever possible. So most of the time we design DTO updates to the backward compatible. We can add a new fields instead of modifying the existing one, and we can mark old fields as like kind of deprecated but keep them temporarily. So basically this allows the older microservices to continue working with being impacted. So this is how we can do that, and we whatever changes log we have done, so this change log we shared across the team, and we let the whole team know like what changed, and where what we can use and which properties has been added, and which version they should use, like who can use which version. So those things are clearly mentioned, so that is how we can do it. Yeah.
Okay, so let's say we have a scheduled task and sometimes it executes more than once in a Spring Boot microservices environment. So what do you think, what can be the reason behind this? Why this duplicate job is running?
uh yeah, so schedule job running like more than once, usually that indicates that the job is being triggered by multiple application instance, or maybe the configuration itself is duplicated. So there can be both scenarios. Let's say we have a multiple instance of the same microservices are running. So if the services is deployed on multiple nodes, let's say sometimes it is on Kubernetes or Docker, so each instance will run its own scheduler. Okay, so it can result to duplication of the multiple execution. Sometimes there can be like same cron logic appears. So if two different classes in multiple configuration files, we have same cron logic, so in that case also, like accidentally we have enabled like in both of the places, so in that case also it is possible. Also there can be one scenario, we have a annotation called enable scheduling, at the rate of enable scheduling annotation. So that might be added in main application class as well as the configuration class also. So if it is added at the both of the places, then also the chances are there it will run twice. So yeah.
Okay, so suppose if we are using quad scheduler, so do you think it will help?
Yeah, so using quad scheduler can help in the situations where like scheduled jobs are running multiple times across the microservices instances. So like Quads basically supports clustering. So when multiple instances of a service are running, so only one instance executes a given job at a time. So that basically prevents the duplication execution of the like in the distributed environment. And also like Quads provides flexible scheduling options. Like it has like such as calendars or misfire instructions and complex triggers. So all those things are there. So we can easily manage that, and most likely the duplication of the scheduler will not happen. And Quad provides tools to monitor, pause, or resume or reschedule the jobs. So that also basically helps to manage the job more. I mean, easily in the production. So yeah, that will definitely help. Yes.
Okay, so what is the difference between annotations, auto-wired, and inject?
Auto-wide and inject. Yeah, auto-wide is a specific to Spring, and it supports required or optional injection, and it can be used on constructors, fields, or setters. So it can be used with them. And inject is, I think, that is Java CDI standard. So functionally it is similar, but it does not support, we cannot say required equal to false or something like that, like we can do in auto-wide. So yeah, so that's the main difference between these two. Yeah.
Okay, and how does Spring Boot handles exception globally?
Yeah, to handle it globally, we can use at the rate of controller advice, and that we use along with the at the rate of exceptional handler. So to handle the exceptions at global level, we can use these two annotations. Let's say whenever we have any exception class, let's say global exception handler we are writing. So at the class level, we can write at the rate of rest controller advice, and at the method level, we can write like at the rate of exception handler, and there we can return the response entity. So yeah, so that is how we can do the global exception handling.
Okay, so what is a Spring Boot actuator?
Yeah, Spring Boot actuator basically it provides the production ready monitoring and management features. So it has various endpoints. So like we have like health is there, matrix is there. So health shows the application's health, and then we have matrix, so that also provides the matrix like JVM memory, all the requests, so those things we can see. And then we also have info, we can see custom info like version and all the build, so those things we can see. And then we also have environment, so like environment properties it will show. So similarly we have several other endpoints also, so that mostly we can use for the monitoring purpose of the microservices. Yeah.
Can you tell me the difference between annotations, request param, and path variable?
Yeah, request param basically it extracts the query parameter from the URL. So sometimes we have a URL like let's say search, then question mark, and then let's say name equal to some ABC whatever. So there we in the get request we write at the rate of request param annotation, and then in the brackets we can write name. So this is how we can get the data from the name, whatever the value along with the name. But path variable basically extracts the value from the URL path. So in suppose we have to do through the path variable call, in that case it will be like, let's say, books then forward slash 123, let's say. So this 123 we want whatever the book object is there along with mapped 123 ID. So for to receive this 123 number, so we can just say add it to path variable and then let's say ID in the quotes, and then like long ID we can just receive it. So that is how we can do that. So whenever we have the URL like forward slash in the path variable, then we can use that. And if we have like question mark, then key equal to value, then we can use request param. So yeah.
Okay, fine. So how does Spring Boot handles JSON conversion?
Yeah, for JSON conversion, Spring Boot uses, we have, I think, Jackson library is there. So it uses that library internally, and objects returned by the REST controller are automatically converted to JSON using the Jackson's. We have, I think, object mapper. So we can customize serialization and deserialization using the annotations. Also, we have like I think at the rate of JSON ignore, so something like that. So like few properties are there, annotations are there, so we can use those annotations for that. Yeah.
Okay, so in microservices, can you give me the points? Like, what is the difference between monolithic and microservices architecture?
Yeah, monolithic, like for example, if we have to deploy, then monolithic will be deployed as a single unit. If suppose even like hundreds of modules are there, they all have to bind together and to be deployed together as a single unit. But in microservices, we can deploy independently. So that is one thing. And then like for the scalability, so whole app will be scaled if we are coming into case of the monolithic one, and in microservices only individual service will be scaled. That's another difference. And then suppose because of this, if suppose if single failure, anywhere some failure is happening in case of monolithic, the whole application will be down. So that is the major disadvantage of that. But in microservices, if any specific module is failing, so we can use fault tolerance or histories. There are various ways using that we can handle that. So we can throw, instead of uh, making the whole system down, we can, for that specific module, we can just say temporarily message we can show to user like why it is down or something like that, or some appropriate different method calls we can do. So the technology wise, we have to use single technology or single tech stack for the monolithic one. But in microservices, some modules will be in Java, some modules will be in .NET, some modules will be in Python. So it doesn't matter. Yeah. So these are the basically, I think, main points for difference between these two. Yes. Yeah.
Okay, and what is service discovery?
Yeah. Service discovery basically that helps microservices to find and communicate with each other without hard coding IP addresses. So it will be dynamically generated. So every time, suppose one service is trying to call another service, so they don't have to like get the hard coded IPs. So it will be dynamically generated. And basically, it is of two types. One is the client side discovery, and one is the server side discovery. So client side discovery, basically service requires services queries a registry. So for example, Eureka is there, and then service server side discovery is that like load balancer queries the registry. So like for example, Spring Cloud load balancer is there, so that queries the registry. These are the two types. Yeah. So we have Eureka, console, Zookeeper. So these are the tools are there for this. Yeah.
Okay, and what is API gateway? And can you tell me why do we use it?
Yeah, API gateway basically it acts as a single entry point for all clients which is trying to access the microservices. So that is the major advantage. So all the request which client is trying to make, they have to go through the this API gateway itself, not directly to that specific module or those microservices. That is the main advantage, and it's like it has various responsibilities. So for example, uh, like as I told, routing request to appropriate services, that is the main work of it. And apart from that, authentication and authorization also we can do, and rate limiting also can be done, and also the logging and monitoring also we can do here. So all those things are done here. Yeah.
Okay, can you tell me the difference between vertical and horizontal scaling?
Yeah, so in microservices and all, we usually use, like we say that that is for the horizontal scaling, and vertical scaling is basically our monolithic applications and all. So like vertical scaling means that adding more resources, so that CPU, RAM, storage to an existing server or instance to handle the increased load. So that is what is called the vertical scaling basically. And we keep the same machine but we make more powerful to that machine. So for example, earlier the RAM was 8 GB. Now since the load is coming up, so we increase that RAM to 32 GB. So that's the scaling. So it is basically simple to implement when the application is small, and it is less complex than horizontal scaling, but it is limited by the hardware capacity, so it cannot be scaled like infinitely. We cannot scale it, and there is a single point of failure. So if the server goes down, the application will be completely unavailable. So that's what is the main disadvantage of the vertical scaling. Now coming to horizontal scaling, so that means that adding more servers or instances to distribute the load. So we are not increasing the same machine, we are not upgrading that, but we are adding more instances of the similar kind of servers. So each new instance handles the part of the workload. Okay, so like for example, running multiple instances of a Spring Boot microservices behind a load balancer, and deploying the several pods of a services in Kubernetes. So all these are examples, and its main advantage is like it can scale almost we can say almost infinitely. It can be scaled by adding more instances. So it is highly available and it is fault tolerance. So these are the advantages of this, and cons we can say like it is kind of more complex architecture, so it requires load balancer, service discovery and all. So that is the con of it, but yeah, but mostly for the complex applications and all, we are using this horizontal scaling itself. So yeah.
Okay, so you have experience on Java 8, right?
Yeah, I have, yes.
Okay, so what are the features you have worked on in Java 8?
Yeah, I have worked on Lambda expression, functional interface, then stream API and default and static methods, and optional class, uh, the new datetime API. So yeah, so these are the uh, features I have worked on mostly. Yeah.
Okay, so can you tell me when have you used optional in Java 8?
Yeah, I have used optional primarily in repository and service layer to handle the potential null values and avoid null pointer exception. So for example, let's say we have any repository, and let's say any product repository is there, and we are saying that find by id, product repository dot find by id. We have the method, and the return value we can gather in the optional. So optional of product, we can gather that. So instead of returning null when the product is not found in this case, then optional wraps the value, and this allows like kind of safe handling of like absent values using the methods like is present, if present. So all that we can use after that. So yeah, so it mostly handles the non-pointer exception. Yes.
Okay, so can you tell me the difference between optional.off and optional.off nullable?
Yeah, so optional dot off we can use whenever we are sure that the value will be never null. So in that case we can go for the optional dot off, and whenever the we know that value might be null and we want to handle it safely, in that case we can go for the optional dot off nullable. So whenever we are using optional dot off, so it will throw null pointer exception actually if the value is null, and optional dot empty will be returned if whenever the value is null in case of optional dot off nullable. Yeah, so that's the difference between these two. Yeah.
Okay, so if that is the case, then why can't we always use optional dot off nullable? We can use always this, right? It will handle it safely. Null pointers.
Yeah, it all depends on basically the scenarios, like what is the use case when we are using. So while optional dot off nullable is safer for like null values, so but there are important reasons to use why we want to use optional dot off, because optional dot off basically uses fail fast approach. So it throws the null pointer exception immediately if the value is null. So there might be some scenario like we want to catch programming errors early rather than silently wrapping the nulls. So sometimes we want to catch them. If any error is there, then we just want to stop or whatever action we want to take. So in that case, we will be using optional dot off, not optional dot off null level. So if a method is expected to always return a not null object, then using off that will ensure that the this is always enforced. Okay. So yeah, so that is why it's I mean it all depends on the scenario when we are using it.
Okay, so what is the difference between comparable and comparator?
Yeah. So comparable, basically the main purpose of comparable, so that defines the natural ordering order of the object, and comparator basically defines the external or custom ordering. Okay. And also in the comparable we have like a compare to method is there, and like only one input parameter it accepts, and in comparator like it has a int compare method is there, so it accepts two parameters. And then comparable is basically implemented inside the class, and comparable comparator is implemented separately outside of the class. And also in comparable, like there is only one way to sort will be there, and that natural ordering will be there. And in comparator we can define multiple sorting strategies, depends on what logic we want. So if you want to use like a comparable, so we can simply say like collections dot sort. So it will automatically sort it. And if we want to use a comparator, then collections dot sort, and inside that the list will be there, and another parameter will be the comparator that comparing will be there. Yeah, so that is the difference between these two. Yeah.
Okay, can you tell me the difference between string buffer, and string builder?
So string is like immutable, and string buffer is mutable. String buffer and builder both are mutable, and string is thread safe, and string buffer is also yes thread safe, so it is synchronized, but string builder is not thread safe. That's the reason the string builder is the fastest, and the string buffer is little bit slower than the string builder. String performance wise it is slower compared to both string buffer and string builder. And suppose if we have any string s equal to, let's say any string is there, any, let's say hello is there, and again we say s plus uh, any other word, so it will create a new object out of it. So it is uh, best for fixed and rarely changing strings. So that's what is that. And string buffer is slower than the string builder due to synchronization overhead. So string buffer provides a like append method. So with that, so whatever string we have string in the is there in the string buffer. Further, if you want to append, we can append with the append method. And similarly, in the string builder also we can do the same. So yeah, so that's the difference between these three. Yeah.
Okay, can you tell me the steps to make a class immutable?
Yeah, we have some set of steps. So first of all, we can declare the class as final. So that is the first step, and then we can make all the fields inside that class as private and final. So we can ensure the fields cannot be changed after object creation. So that is the purpose of it. And then we can initialize all fields via constructor. So that set all values at the time of object creation. So and then after that we do not provide setter method, so only getter method will be there, so that we can avoid modifying the fields after object creation, and then we can and if the field is a mutable object, for example a list or date is there, then we can return a copy in the getter, or we can use the defensive copying method. So these things we can do. So yeah, so these are the steps are there.
Okay, so how do we compare the string? So we use double equal to or equals method.
Yeah, so basically double equal to operator that compares the references, means memory addresses, not the content. So it will return true only if the both string object points to the same memory location. So suppose if we have any s1 string equal to let's say hello, and s2 equal to also hello, okay, and we have s3 equal to new string of hello, okay. So this s3 is now altogether different object. Now whenever we are trying to compare s1 and s2, so it will always return true because it is coming from the string pool. But if suppose we do s1 equal to double equal to s3, in that case it will return false because s3 is altogether different object. Or if we say s2 double equal to s3, that will also return false. And equals method, it will compare the actual content of that. So usually in case of a string we use equals, because we normally we want to use compare the content, not the memory address. So we use equals method. Yeah.
Okay, so when to use concurrent hash map over collections dot synchronized map?
Yeah. Concurrent hash map, it allows the concurrent read and write operations by multiple threads using the bucket level locking or segment level locking. But collections or synchronized map, it synchronizes all operations on the entire map actually. Okay, so that means that only one thread can access it at a time. So multiple threads cannot access it. So that can create the performance bottleneck under the heavy load. So that's the major difference. So concurrent hash map performs better in multi-threaded environment because threads can work on different segments simultaneously, and synchronized map may become like a scalability problem when many threads are accessing it. And apart from that, concurrent hash map does not allow null keys or values, and synchronized map allows one null key and multiple null values. So basically, in short, we can use concurrent hash map for high concurrency scenarios where many threads read write are happening frequently, and we can use synchronized map only for the low concurrency scenarios or when we need a legacy synchronized wrapper. So in that case, we can use the synchronized map.
Okay, so in JPA, how do we write custom queries in Spring Boot?
Yeah, so we can use at the rate of query with JPQL. So whatever the repository class we have, so or interface we have, so there uh, let's say we have a like public interface like ABC repository that extends JP repository. Okay, then on top of the method below that interface, so whatever the method name we want, so that we can give method name, and on top of that which query it should use, that we can write, and that query we can write inside the brackets, small brackets, and add that query, small brackets, and then we can write that. So that is how we can write the custom query.
Okay, so now can you tell me what is the difference between save all, and flush? So that in Spring Data JPA, can you tell me?
Yeah, so save basically persist a single entity to database, and save all persist a collection of entities. So that's the main difference between these two. And flush, I think that forces pending changes in the persistent context to be written to the databases immediately. So then we use flush, I think. Yeah.
Okay, and what is the difference between fetch type lazy and fetch type eager?
Yeah, lazy basically that relates the entities like all the related entities are loaded only when the accessed. So it uses the process objects basically. So, but eager will be loaded immediately. So all the related entities will be loaded immediately along with the uh, parent entity. So yeah, so that's what is the eager.
Okay, so what will happen if you don't specify at the rate of table on the entity class? So have you ever tried that?
Yeah, at that of table, if we don't mention, then I think by default JPA uses the entity class name as the table name. So
Okay, and it uses it in lowercase, uppercase, anything like that also happens?
yeah, I think it does in the lowercase. So it uses the entity class name as a table name in lowercase.
Okay. And what is the difference between char and varchar? Do you know?
Yeah, yeah. So char is fixed length and varchar is like variable length. So it is more memory efficient varchar. Like even though suppose we are giving the, we don't know like how much characters would be coming to a specific column in the table. So in that case we can use varchar. So it will use only whatever is required and it won't use the like, let's say how we do in the char. So in char suppose we assigned with 100 characters. So irrespective of what we are using, it will still be occupying the 100 characters. So yeah.
Okay, so why don't we use varchar itself always instead of char?
Yeah, so varchar we cannot use always because like see char of, let's say whenever we have the kind of gender thing, okay, so we know that it will always occupy only one letter, only one character, right? So it can be M or F like that. So it, in that case it is better to give char only, or suppose we have country codes like US, IN, or let's say we know that all the country codes will be of at most two characters only. So we can just say char of two. So it is good in that case. We can use char in that case. But varchars like suppose the user names which is always variable, emails or some description variable length is there. So in that case we can go for the varchar. So basically like fixed length columns like char, it is more efficient for indexing or in certain DBs and all. So basically the performance also of char is faster if we give char of 1, 2 and always like whatever entries we are using in that. So it will be faster instead of varchar. So yeah.